Audio Jungle. Audio Jungle.
We have to calculate moment of inertia for I section first. So moment of inertia for I section. Okay, in I section also two types of I section we have: asymmetric, I that is symmetric and unsymmetric. Okay, so here first problem we are going to solve, that is symmetric I section. And in symmetric also, it's again it is divided in two parts. It is symmetric about x axis, or symmetric about y axis, or symmetric about both axes. Okay, if you talk about the symmetricity, so symmetricity also it defines, it is symmetric about x axis, or symmetric about y axis, or symmetric about x and y axis both. If symmetric about x and y axis both, then it is called bisymmetric. What it is called? Bisymmetric. So I am going to talk bisymmetric I section. Bisymmetric. Bisymmetric. Okay, I section we are going to talk bisymmetric, means symmetric about x axis as well as y axis. Now, so need to focus here. Right. And if you see if you see both side, okay, maybe diagram will not be accurate, but dimension I will give, so you have to consider both side dimension must be same. It's nothing but 180 mm. 180 mm. This is also 180 mm, right? This is 10 mm. And here also it's a 10 mm. This is also 10 mm. All right. Now, so basically this is what uh, uh, x symmetric about x axis as well as y axis. Correct. Now, the vertical dimension from this end to this end is nothing but 400 mm. Right. Okay. Now we need to calculate moment of inertia for this I section. And that too, moment of inertia, as I told you, it's symmetric about x axis as well as y axis. So now here I am interested to calculate moment of inertia about x axis. So I can take x axis somewhere here. Now this is the x axis. Okay, I'll draw it. X. This is x coordinate and this is y. So we need x axis. This we need. Okay, or better, I will give the capital. So capital XX and capital YY, that will be better, no? So I need IXX, that is the capital value. Okay, how to get it? It's very simple. How many section we have? Simply, just for understanding only, we can combine this. So this is section number you can say 1. This is section 2, and this is what, section 3.
Sir, 1 and 3 though will be same. No?
Sorry?
For 1 and 3, it will be the same only.
Yeah, it's a symmetric about x-axis as well y-axis both. That is true. That is true. So what my point is, total moment of inertia for x-axis will be I xx1, I xx2, I xx3. And yes, you are right. xx1 and xx3 must be same. No doubt about it. Right. Now we have to work for it and we'll see what value we are getting. So now listen. What we'll do, we can take this 1 2 3 section, one section we have to take, and then we have to perform calculation for it. Okay. Similarly, we'll perform calculation for second section, then we'll calculate for third section, and obviously we'll combine. Then we'll have the total moment of inertia, which is about x-axis. Right? Correct. So now onward, we have to vertical distance, whatever it is given, 400 mm. So again we'll identify, like if we'll calculate this vertical height, so how much it will comes. Okay, how much it will comes. And then obviously few section like one section will do, like section 1 2 3, right? 1 2 and 3, right? Both 1 2 3. If you check, the value of cg we have to also find, because that is important. We have to find the area also, then we'll go for the calculation. Okay, then we'll go for the calculation. Now if you check dimension for this is nothing but 10 mm. This is nothing but 180, right? Similarly, this is also 10 mm, and here it's also 10 mm. Now see the second section, that height, or you can say it's a vertical length. So what will be the vertical length here? What will be the vertical
3,
length? Obviously
380.
10 mm downside. See, no, we just see here. It's a 10 mm here, it will cut, and 10 mm here it will come. So total 20 mm. So 400 minus 20, how much it is? 380 mm, right? Now onward, calculation, what you have to perform? First you have performs area. So what will be the area? Area, we can say it's 180 into 10, which is nothing but, and similarly we can go for the area for two sections. It's a 10, and third it's nothing but, okay, obviously here also it's a 180 mm, so it's nothing but mm square. A1 A2 A3 separately for the section we have calculated, right? Now this is the one thing. Second thing, also very important, that is CG location. For each and every individual we have to calculate CG location. Now see, if this is the rectangular section, so how to get CG location? You just draw diagonal here. This is also diagonal. So this will be the CG location, and this CG location, okay, depends. like from where we are calculating the CG location, from where we are calculating the CG location, right? We are calculating from base or we are calculating from the top, right? It's our reference we have to take. So initially you just concentrate for this. So here the CG1 is nothing but 10 by 2, that is 5 mm, because this is the section 1. So I have given name CG1. Similarly for this section you have to calculate CG. This will be the CG location. CG2 380 divided by 2, which is nothing but 190 mm. 190 mm, right? 190 mm, that is the CG, individual CG location for section 2. And similarly here, if you want to calculate CG location, then CG3. So it's also 10 by 2. Till now, this is the individual CG location or centroid we have calculated for individual section 1, 2, 3. Reference we have not taken. Reference will take once we'll combine all three. Then I will show you the reference. Okay, then I will show you the reference. Right. Now, coming to the next, if you check here, combined section. So right. Now, so suppose we are interested to calculate the CG location with respect to base. I'm interested, suppose, to calculate CG location with respect to base. So now this is the base, this reference line. Very basic I'm explaining. If you learn this basic, then for each type of section you can calculate. Now this is what base. This is the base. If you check from this top, this is the top, right? And this is what base. Top to base, if you check what is the height, it's 400 mm. See the problem, it's a 400 mm, no? It's a 400 mm top to, this is the top and this is the bottom basically, and this bottom is nothing but your base. This is the bottom, but bottom is your. So all CG you have to calculate with respect to base only, with respect to bottom only, right? Now I can get here, I can get for section this one, this is the section 1 here. Okay. Similarly, thing not required. You just mark easily because you have calculated, right? Again, why you will cut section and so much things in this diagram. Your CG location somewhere at mid for this section, at mid for this section, and it's nothing but, because everything we are measuring with respect to base. So here this is your CG location, and this CG location from base you now need to calculate. See, this CG location for this section was, it was 10 mm, this was 10 mm, right? So CG location was 5 mm for this. See here, just now you have seen this was the 10 by 2 5. This was the CG location, this was the CG location, CG1. This is the CG2, and this is what, CG3. Your for with respect to this section 1, this is section 1, this is section 2, and this is section 3. So with respect to section 1, you can check total height is 400 mm, and if you see in between, this is what, 5 mm, This is what 5 mm. Total is what 10 mm, right? So now from base, if you calculate CG1, then what will be the location of CG1? It is 400 minus 5 mm. That upper side, this value, this 5 mm will be reduced. Nah? This is the 5 mm. So what is this side? This is nothing but 395. This is the CG location of section 1 from the base. Hope you understood this. This is the CG location. Okay. CG location from the base. CG location from the base. All right. We are calculating all CG location from the base. Reference is base. Now, for this section, it is, if you combine this lightly, so this will midpoint will be the CG location, and this CG location is nothing but CG2. You also have to measure for this also with respect to base. What is with respect to base? You check now onward, because for this section, you had calculated how much it was there. It was 380 by 2. But for this up to second only, but in with respect to base, this 10 also will be added. This was the, I'll show you, this was the value you had calculated here. That was the 190. That was the 190, right? This was 190 mm. But with respect to base, again 190 plus this is what, 10. So what is this value? This is nothing but 200 mm. Right. Now coming to the third, this is the CG3. Okay, CG3. So with respect to base, what is this? This is nothing but 5 mm. Right. This is nothing but 5 mm. You need to remember, this is the section 3. So for section 3 with respect to base, you have calculated 5 mm. For section 1, it is 395. For section 2 with respect to base, it is 200 mm. Right. Now we are going to calculate Ixx1. Now listen carefully, you will understand. We are going to calculate moment of inertia about x-axis axis. Where is the x-axis axis? This is the x-axis axis. This is x-axis axis. Okay. This is what x-axis axis. About this, we are going to calculate moment of inertia, Ixx. So what is Ixx? It is Ixx1, Ixx2, Ixx3. Right. Anyway, so check first section Ixx1 with respect to CG. So I will show for Ixx1 calculation first. Ixx1. Where is Ixx1? This is the section 1. And this section 1, you are going to calculate moment of inertia for capital XX. Obviously, this Ixx1 will be for this CG. This Ixx1, you are Ixx1 you are going to calculate for section 1. But about which axis? About I capital XX. Where is the capital XX axis? That capital XX axis is what, somewhere here. This is the capital XX axis. Concentrate, you will understand, it's very easy. Ixx. Ixx is here. Your section 1 is what here. Now you have to use the parallel axis theorem. I had explained if you calculate moment of inertia for the any section, and if it is across the CG, this is the CG axis, this is the CG axis. Okay, this is the CG axis. Okay, so for the CG axis, obviously this is the rectangle, so it's a BD cube by 12, because this section is what, rectangle section, rectangular section. Okay, so what is the ICG1? What is the ICG1? Best I will write ICG1. What is the ICG1? ICG1 means for that section across CG, what is the moment of inertia? It's a BD cube by 12. BD cube by 12, or I had explained BH cube by 12. This was given last class. Okay, right. But I'm not asking about the CG. I'm asking about this x-axis axis. So if you are calculating this x-axis, so you have to use parallel axis theorem. By parallel, last class only I had explained parallel axis theorem. So if axis is what passing through the CG, and for that axis only you are calculating moment of inertia, so direct formula you can write for rectangle, it is bh cube by 12. But you are interested to calculate moment of inertia which is somewhere other place, which is not that axis which is not passing through the CG. That axis was somewhere other place, like this xx. This is not passing through CG. This is some other place. So now for this, if you want to calculate moment of inertia, you have to apply parallel axis theorem. Nicely, last class it was explained when parallel axis theorem we have to use. What is the parallel axis theorem? To calculate moment of inertia about for any axis xx, that time that formula will be I cg1 plus area of section 1 into perpendicular distance. I can consider this perpendicular distance, just say this is the y1, so it's nothing but a1 y1 square. This is the parallel axis theorem. I hope this one is clear. So obviously this ixx you are calculating for section 1, so I have to write ixx1. Okay, ixx1, I am writing ixx1. Anyway, now coming to this, so ICG1, it's very easy. BD cube by 12. B is nothing but width. It's nothing but 180 mm. 180 mm. Depth is nothing but 10 mm. 10 mm. So you can write 180 into 10 BD cube by 12 plus area A1. Just now you have calculated here. It's nothing but 1800. It's nothing but 1800 into y1. Y1 is the location of CGs of section 1 from the axis where you are calculating moment of inertia. From that axis you are interested to measure the CG location. So from XX, what is the CG location? Now check. This is your XX. From CG, this is your CG. Just listen carefully, you will understand. Okay, you will understand. This is XX axis. Here you are calculating moment of inertia, and this is the CG location of section 1. What is this height? Now concentrate. If you check, this height is nothing but, you can say total is nothing but 395. See, total is nothing but 395. Nah? So total is nothing but 395 minus you have to remove this whole section. So this is nothing but 190. This is nothing but 190 and 10 means 200 you have to minus, reduce. 200 you have to reduce from how much? 395. So it's nothing but 390 minus 200. 395 minus 200. Check carefully, you will understand. 395 minus 200. 395 minus 200 will be the distance of y1, right? Distance of y1. So 395 minus 200 is nothing but 195. It's nothing but 195. So I can take 195. You have to calculate this. This is for section 1. Similarly, we have to calculate for the section 2. So where is the section 2? We'll see here. This is the section 2. Now check. First calculation you have done for section 1. Now we are calculating for section 2. This is the section 2. And here if you check about where is xx, this is what xs. And if you check, this xs is what passing through CG2. So here we don't require the parallel axis theorem, but if you want to use, then I will tell you how to use. That is also interesting. So ixx2, if you want to calculate, then you have to write bd cube by 12. See here, this is nothing but 10 mm, and if you see the vertical height for this section is nothing but 380. 380, na? It's a 380 here. 380 mm. So we have to write Ixx, which is nothing but 10 into 380 cube by 12 plus area, that is A2. What is A2? Previously only you have calculated 3800. 3800 into y1. What is the y1? Y1 is the distance of CG location from the x-x axis. Now see the diagram properly, you will understand. This is the CG2 location, and what is the distance of CG2 location from x-x? It's the same only. It's the same only, right? It's the same only. So what you can say, that distance is nothing but y1 is nothing but 0. Right? So here you will get Ixx. Right, this is the approximate value of Ixx2. Similar, this is the section 2, right? And this is what section 1. Similarly, we have to go and perform for section 3. Where is section 3? If you check, section 3 is what, somewhere here. This is nothing but 180. This is 10. And if you check, where is x-x axis? This is our x-x axis. This is the CG3. This is nothing but y3. And obviously we are going below to x-x axis, so this y3 will be negative. Always remember, because x-x axis is a reference. If you are going this upward direction from reference axis, so it will be positive, and if we are going, then it is negative. But don't worry, this is a square only. This is the square value only, so nothing to worry about plus and minus. Okay, now if you calculate Ixx3, then it's nothing but Cg3 plus A3 Y3 square, right? What is the ICG3? If you check, it's nothing but 180 into 10 cube by 12 plus area is nothing but 1800 into Y3. Now you have to check Y3. How to check Y3? See, check the location from,
It will be 195 on it.
yeah,
Sir.
190.
195.
Yeah, 195. Correct. Very good. So it's nothing but 195. Remember, this 195 is negative value, okay? And negative, why negative? Because you are going from downside from reference, but it is a square, I told you, so there is no effect. Calculate Ixx3.
So it will come the 15, what do you call that?
Huh?
It will come the same
Same.
6842.
Right. Tell me.
6846.
Tell me. 6?
846.
Huh?
And then 4 times 0.
I believe that you are completely understood I section. Yes or no?
Yes, sir.
Very much I have integrated this. Means each and every part separately I have explained here. So I believe that now it's okay.
Yeah.
Right, this is the Ixx3, and you can see here Ixx3 is nothing but Ixx1. So same only, Ixx1, because it's a symmetric. So Ixx1 and Ixx3. Now if you want to calculate total Ixx for the complete section, so it's nothing but Ixx1, Ixx2 and Ixx3. We add all three and then calculate Ixx. Tell me.
Sir, it is coming 1.826 into 10 raised to 8.
1.8
826 into 10 raised to 8.
10 raised to
8.
8. Then this is the moment of inertia for the complete section Ixx. For complete I section, we have calculated Ixx. That's all. Done.